What is oscilloscope sample rate for electrical engineering? Imagine trying to catch a fast-moving ball with a camera that takes only a few pictures per second. You might miss the action or see a blurry image. That's similar to what happens when measuring electrical signals with an oscilloscope. The sample rate is the key to capturing those signals accurately. In simple terms, the sample rate tells us how many data points the oscilloscope records every second from the electrical signal. Think of it like frames in a movie. The more frames per second, the smoother and clearer the motion appears. If the sample rate is too low, the oscilloscope might miss important details or create misleading images of the signal. The sample rate is closely linked to the bandwidth of the oscilloscope. Bandwidth is the highest frequency the device can measure accurately. To get a true picture of a signal, the sample rate should be at least twice the highest frequency component. This idea comes from the Nyquist sampling theorem, which says that you need to sample at more than twice the signal's highest frequency to avoid errors called aliasing. Most oscilloscope manufacturers recommend a sample rate that is about 2.5 to 5 times the bandwidth. For example, if an oscilloscope has a bandwidth of 100 MHz, a good sample rate would be around 250 megasamples per second or higher. This helps ensure the captured data reflects the real signal, even for complex or fast-changing signals. A higher sample rate allows for better reconstruction of the original waveform. This is especially important for digital signals or when analyzing transient events that happen quickly. But keep in mind, faster sample rates fill up the oscilloscope's memory faster, which limits how long you can record a signal at that rate. When choosing an oscilloscope, it's essential to consider both the bandwidth and the sample rate. For most measurements, a sample rate of at least 5 times the highest frequency you expect to see is a good rule of thumb. This helps prevent aliasing and gives a clearer picture of the electrical activity. In electrical engineering, understanding the sample rate helps you pick the right tool for your measurements. It ensures you can analyze signals accurately and troubleshoot issues effectively. Remember, a good sample rate combined with appropriate bandwidth makes all the difference in capturing the true behavior of electrical signals.